Okay, class, we're going to look at graphs and functions. This is the second lesson in Chapter 5. Okay, we need to take care of some vocabulary first. A relation, it's a set of ordered pairs. An example of a relation would be if we were talking about giraffes, where we have a set of ordered pairs where x coordinates are your ages of the giraffe and the y coordinates are your height of the giraffe. This is an example of a relation. It's just a set of ordered pairs. It could be about anything, just any random set of ordered pairs. A domain, these are the input values of a relation. These are values you put in if you have an equation where you're plugging in for x. That is your domain. The numbers that you're putting in are your domain. The numbers that you come out with after you put x in are your range. Those are your output values. So you put in a number for a variable like an x. You come out with something that's called a range. Your independent variables are always the domain, and your dependent variables are the range. Now the difference in independent and dependent variable, there's always one variable that depends on the other, and that's how you can tell the difference in independent and dependent variables. Function notation is a notation used for functions. We will talk a little bit more about that later in the video, but we are going to use this notation right here, f of x. This represents an output. It represents like a dependent variable or a range value. We call it f of x. And we're going to talk about what functions are next. Okay, on example 1, we need to determine whether a relation is a function or not. A relation, again, is a set of ordered pairs. Some of those relations we will be able to call a function. And in order for something to be a function, it's a relationship that assigns exactly one output value for each input. What we're going to do in example 1, on your paper, you need to write two boxes. You need to draw two boxes under example 1. One box is going to represent your x values, and the other box is going to represent your y values. So this would be your x, this would be your y. Okay, those are your x values, these are your y values. And then we're going to draw arrows. Okay, we're going to draw arrows to line up each x value with the appropriate y value. So if we line up 11, oh, I'm sorry, my ink's still on. Okay, so then if we line up the 11 with the -2, the 12 goes with the -1, the 13 goes to the -2, and 12 goes to 7. So you can have two of these going to one y value. Two x's can be going to one y. Okay, it is a function because two x's can go to one y. It can't go the other way though. So each one of these has to go to, two of these can go to one y, but you can't have two of these go to one output. Okay, an example you'll see is the next one. For example 2, go ahead and draw your x and your y maps, or your boxes for your x's, and then here's your values for your y's. And notice if you have an x value that's listed twice, like -2, you only list it once in your box. And then we go ahead and line up the pairs. So -2 goes to I'm sorry, this right here should be a 1. And then we have, oops, -1 goes to 0, 6 goes to 3, and then -2 goes to 1. Okay. I believe actually where the mistake is on here, this right here should be a -1. So on the first ordered pair, on example B, change that to -2, -1. Now, this is not a function because you can't have two arrows coming from your x box to your y box. So -2 on the x's is going to two different ones on the y. So this one is not a function. Okay, -2 goes to two y values. You can't have one x going to two y's. You can have, I'm sorry, I said that wrong. Okay, you can't have one x go to two different y's, but you can have two different x's go to the same y. Okay, there's another way to tell too. It's called a vertical line test. If any function passes the vertical line test, it would go through more than one point on the graph. So in a vertical line test, if you look at each of these two functions, okay, the one on the left is a function, the one on the right is not. And the reason is because if you can take a vertical line through any part of the function, and if it hits your vertical line in more than one place, then it is not a function. So notice the difference. Here it hits it here, here, and here. And then on the left, no matter how you take that vertical line, if you take your pencil and go all the way across the function, there's no place where it will hit your vertical line twice. So this one right here is a function. Okay, that's another way to tell if something is a function. We're going to determine whether example 2 is a function or not. What we're going to do is, instead of doing our maps like we did on example 1, we're going to actually put these points on a graph. Okay, these points are on a graph. I've labeled them right here on the graph. And we can see that it's not a function. And the reason it's not is because right here at 2 on the x-coordinate, there are 2 values that fall there. So if we can draw a line there. So there's a vertical line where this function would hit it in 2 different places on the vertical line. Therefore, it is not a function. Okay, example 3, making a table from a function row. We're going to be doing this quite a lot over the next few days. We're going to use 1, 2, 3, and 4 as our domain values. Those are our input values. If you remember, you need to get the words domain and input kind of put together. And independent variable. Independent variable, domain, input values, all of those are the same thing. We're going to plug in for n 1, 2, 3, and 4 into this function right here. We're going to come out with an output value here. So you're going to be doing quite a few of these tables. So for instance, the first one, we put a 1 in for n. So we get -2 times 1 squared plus 7. If we simplify that, we get a 5. We're going to do that with 2. We get a -1. If we put 3 in, we get a -11. We put 4 in, we're going to get -25. So we're just plugging the numbers in, getting our input 1, 2, 3, 4. This right here is our domain. These numbers here are what we call the range. So this we call the range. And this one over here is called your domain, because these are the values that go in, and then you come out with values called your range. Okay, so these are your domain or your input values. This is your range or your output values. All right, clear that ink. Okay, finding the range. So here it says to use the domain. They tell you the domain this time, -2, 0, and 5. We plug it in just like we did before. Plug in -2 for A, you get 11. Plug in 0, you get 5. Plug in 5, you get -10. So this right here is our domain. Now, these are our range. And how we can answer this question is, notice how we have the domain in brackets. Okay, the way that we want to answer this question is we can do a big R with little colon, and then we can do these little brackets, and we'll put 11, 5, and -10. And this represents our range. That is what we were trying to find. And that answers that question, finding the range. So, and then again, I forgot that will show up again, so that's your range, 11, 5, -10. All right, and that is just a simple way to determine whether or not a relation is a function, and then also how to evaluate a function. Thank you for watching.